Right. So before anything, am I audible? Can you see my screen? All that is fine, right? Like, can you hear me? Yeah, perfect. Perfect. So let's begin, right? So basically, who am I? I'm an Android developer. I've been working as an Android developer for almost 4.5 years now. And I have been mainly doing native Android development, but KMM is more of a hobby. I have dabbed in all type of cross-platform technologies, Cordova, right, a bit of React Native, a bit of Flutter, but yeah. So KMM is the one I'm like mostly doing in my hobby projects. So let's begin directly as to on the topic. So it's a question that I need to ask people because often when we talk about Kotlin, we cannot kind of run away from Java because when we started Android development, we started with Java development, right? So if you think about it, is Java truly platform independent? Because I remember when I was reading about computer science, like basics of it in class 8 or 9, when I was like very small, we learned Java as what a object-oriented platform independent programming language, right? But if you think about it, if you want to like Java is called a platform independent, but the JVM itself is often dependent on the OS that it is running on, correct? So Mac OS JVM is not the same as a Linux JVM or a Windows JVM. The JVM is often different, correct? So what is going back, right? In the scenes we have seen this image before when you talk about Java. So there's a Java source code, there's a Java compiler. That bytecode gets transferred to Java interpreter, bytecode compiler, and then machine code that is readable. Correct. If you are going more into it, this is how it actually looks, right? So there's a Java code. It goes through like you go that bytecode is made and it goes to the JVM, which is platform dependent. So every, let's say your Mac OS JVM takes that Java code and then converts it for its Mac system. Windows does it. So that is where the question lies. I mean, people who are starting with multi-platform development, they often have this like just starting out that why don't we use Java since it's platform independent? But it's actually not correct. I think we have fantastic talks on Flutter. A few like in the next sessions, but even then if you see the engine of Flutter is actually shipped with the product, right? So Anna can correct me there if I'm wrong. So since it is shipped with the product, what happens is it adds 2 or 3 MBs, but then what it does is it actually gives you a place where you can show it on the screen and the all the widgets that you are making gets rendered, correct? So that is where I mean, if you had to do that with Java, probably using Java, the JVM would be so large that our app side would go in probably MBs, like 500, 400, 600 MBs, and it would not be very good to run that on a phone device. So that's why we do not use Java as a multi-platform language. What do we mean by a multi-platform language? Because there's a difference. Like I feel I do the demarcation that what is the difference between a cross-platform and a multi-platform, right? So cross-platform technologies like Flutter, like React Native, it's like code once, it works. It looks the same in all devices, correct? So let's say you are trying to make an app for iOS, I was trying to make an app for Android. If you are a business owner, you would probably differentiate between, you would probably make it such that you have an iOS team, you have an Android team, and what that causes is, let's say the bugs of iOS are separate, the bugs of Android are separate. So there are two different teams working in parallel, and they are trying to build this product by themselves, correct? So often, though, that is the reason cross-platform technologies was actually introduced, where we wanted such that there is one code base, there is one there is one place where we get bugs and we can solve them, and there is like one set of developers that have to handle, because in that way the asynchronicity, for example, one iOS team lagging behind or the Android team lagging behind because some feature works in Android, some feature does not work in iOS, this does not occur, correct? So what is Kotlin? I mean, I am like, it would be funny if I asked this in like 4 years ago, where Kotlin was just gaining speed. But now Kotlin is like omnipotent; it's everywhere. So I think everybody knows this. But I'll just, because I have to, I'll talk about it. So it is a language developed by JetBrains, I think 2013. It actually got its push when Google said that it was the official language for Android development, and that is what it has been like. and we have been developing Android Kotlin apps ever since. Like this is exactly like what I feel would. This is exactly how it is when I talk about Kotlin development, because Google first chose that like we would use Kotlin going forward first. Second is like once we start Kotlin, you would not want to use Java anyway, right? And because it has a lot of features, like I'll not go into that those where like null safety and all that. So anywhere that you can use Java, you can use Kotlin now. Now we have to talk about slowly transitioning into Kotlin to Kotlin multi-platform. Correct. Now Kotlin Multiplatform is just a chill guy. It's just a chill guy. What it does is it will take these platforms, right, and it actually works on all platforms, and you have a lot of flexibility as to how you want to share and how much you want to share. Correct. So so this is one place. So for example, you can use Kotlin in the servers. You can use Kotlin Android, iOS, desktop, web. That's fine. That's like people would be like, that is any cross-platform technology is supposed to do that, right? Any cross-platform technology is supposed to be such that you can use it once, and you can like then you can write the code once, and you can repurpose it anywhere. But the funny thing about Kotlin multi-platform is we get to decide as to how much of the logic that is what we want to share. Because if you think about making an app, we might be talking about very big names, right? Like this architecture, that architecture. But in its essence, what we are actually taking is we do the same kind of things. We always, let's say, so let's say we take the data from an API, right? We store the data inside, like a database, right? And then we show it on a screen. That's exactly what you're doing. So, people, we like, I mean, what do you do, right? And we call ourselves software engineers, Android developers, front-end developers, all of that, right? But in the end, that is exactly what you're doing. We just call an API, we take the data, and we show it on the data. Now there's a lot of steps in between that you have to follow to make it scalable, to make it approachable, to make it understandable, and all that. But in the essence, that is actually what we do. Now, what Kotlin multi-platform does is it has found this pain point that in the essence, since the logic part is the same. So the logic part is the same. What we are doing is in a Kotlin multi-platform project, we are keeping the logic part separate from the UI layer. So the logic part, what we are doing there, we are doing the API calls. We are doing the database operations. We are doing, let's say, the save, showing it on the screen is something that is totally sent to the UI layer, right? And we are not kind of getting our hands dirty with them both if we want to, right? Now you see a UI multi-platform section here as well. So Kotlin multi-platform also give us the option that, let's say, we want to share the UI as well. So let's say I'll try to show. So this is a I don't know, like I'll just run it once so that it will take some time. So right, I'll just keep it running so that I can come back to it later. But yeah, so let's say we want to show just the UI, right? We want to share the UI between the desktop. We want to share the UI between the iOS, but we want to keep the desktop UI separate, right? So that flexibility is given to us. But this is exactly what it is. Like I think of it as a vendor shop. KMM is the vendor, and whatever you want to give, you just take it from and choose it. So I'll give you an example. So when I was working in Nika, which is a like a makeup brand, like makeup online e-commerce brand. So what we had was the whole app was in legacy code, almost like it was, the amount of code was almost like a lot of code was something that was written in 2018, 2019, where KMM was not there, right? And similar for iOS. But we wanted to make a library which just tracks the tracking, like tracks about tracks where the user is clicking or all of that. So for that utility, we made a KMM library, and that KMM library was then used between iOS and Android. So even though we have an existing app that has been there for 2018, 2019, or we have you have like something that iOS has been for the same time, even then we could add some value to it. Emma, don't trigger me with that question. I'm just kidding. I'll probably take a like 2 hour session on why Kotlin is better than Java. But I'm just kidding. I'm just kidding. I'll get back to you on that. So yeah. Anyway, so talking more about the UI layer, talk about how we are actually doing it, right? Because let's just talk about, let's keep the desktop part a bit separate, because in the end, Android desktop, both of them work on the JVM. So in the bare metal, the work that is being used to be done is pretty. The work that is being done is pretty much the same, correct? So I'm not going to that, but let's take iOS and Android into question, because those are the mostly widespread mobile platforms, and that is the main place where the difference lies. Correct. So, for example, the rendering, right? How Flutter does it? Flutter ships the engine with it. Flutter ships the engine with it, which acts like a black canvas. And since it is a blank canvas, what it happens is it renders the elements or the widgets on that blank canvas, and it also uses this Skia GL library. Correct. Now, what happens when I come to iOS? In Android, we do not have, we use the Skiko. Like, it's like a fork from Skia. You'll forgive me on this because I haven't worked completely on Skiko, right? But it is like a fork from Skia, as far as I remember. And what it does, it uses that to render the iOS screen with the data that the widgets that we are making. Correct. So that comes that like, let's go to our original question, which was why is Java not platform independent, right? Java is not platform independent because the JVM is dependent, and the JVM takes a lot of size, correct? Since the JVM is taking a lot of space, right? What is happening is, since the JVM is taking a lot of space, we are not being able to shipping it, probably, I don't know, shipping it with like, there will be other issues as well. Apart from that, when you are shipping the libraries, shipping the whole JVM with the small app that we're trying to make is not very, very smart, correct? So how iOS does this, how Kotlin does it in iOS is, there's an LLVM toolchain. It's not an acronym. Like, there's a first thing that LLVM, in the library, if you see, they say that we are not an acronym. But LLVM toolchain, what it does is it kind of converts this Kotlin language into something that the iOS devices can also understand. For JVM, it's very straightforward because Kotlin is a JVM language in its essence when it began. So there is no issues there, correct? So again, this is this is exactly what, as an Android or an iOS or a web developer or anyone, this is what we actually do. We make API calls, we make database operations, we make persistent storage, we make data formatting, right? So in the end, it becomes exactly like, it's exactly what we're doing, correct? But it all sounds very rosy when I put it out. Like, I sound more like a marketing guy than a developer, because it's like, okay, why is this? If this is so perfect, if KMP is so perfect, why not we use it for everything? Correct. So there are some challenges there. For example, let's say you want to get the date from an iOS app, and you want to get the date from an Android app, right? For Flutter, you have a library that would date it. I think it's the datetime library of Flutter. I'm not sure. For Flutter, there's a datetime library, which I'm not sure what the library is, but that would give the date to you, correct? But in Android, or when you're using the Android native libraries, or you are using the iOS native libraries, the problem is we do not, we are trying to write the code once. We are trying to write the code once, and then we are trying to target both these platforms at the same time. So that is where a programming paradigm comes into place, which is called the expect actual programming paradigm. So what this? So if I show you a project, okay, let me show this. Okay, this is a project by one of my friends. It's Abdul Basit's travel app. It's amazing. Like, so it has like 4 or 5 targets. So that's what I used for this demonstration. But if I go to the program, if you see, there's an iOS app, right? There's an Android app, right? And there's a shared section. Where's the shared section? There should be a shared section somewhere. Okay. Oh, sorry, I was looking. Okay. So right, so there's a common main where you write all the code, right? Where's shared? Where's shared? Right, give me a moment. So this is the compose target, Kotlin target. Yes. Right. So basically, yeah. Okay. Common main. So there is this place where you have the common if I go back to the place, we have the common function called, you know, random UUID, correct? Now, problem is when we get the random UUID, we can get the random UUID in two different ways depending on where we are trying to take it. We will be able to take it from Android, we'll be able to take it from iOS, but how they send it is different. Now, this is what is exciting about KMP. What KMP does is, let's say again the purists will kill me, it's supposed to be KMP because KMM was deprecated, but anyway. So what KMP does is it tells us that, okay, I have a function called random UID and it expects a string, right? That is all the common section tells us, but it is on us as developers to supply that string to. So it's basically like a child, right? Basically it's a child who says that I want a chocolate, right? It does not matter if mom gives it to him or if it's a father that gives it to him. It does not matter if your grandma is giving it to him. He just wants a string, correct? So it's a similar case for this section where the common section is expecting a string and your Android section is giving the string in this Android specific method, right? And your iOS is giving you the string by that this iOS specific method, correct? Now you might be under thinking that this is okay for easy use cases, correct? But it's not, right? It's even possible for very complicated use cases. For example, a video player, right? Again, iOS video players are much better than Android video players. Like if you use the iOS like video player in your device as a developer, it's a much better API that to use than your Android. So even if, let's say, there was a library which actually targets both Android and iOS, and you are giving that value to a video player, it would be you're better off using the native components, because video playing, Bluetooth, camera, these are things that are better when you're using the native components, the base metal of the app itself, correct? So when you're using video player, you basically define that you need a video player, correct? You give that there is a modifier that you need to give, and then is a video ID, correct? Now this is where it demarcates. This is the expect version. So this is the kid who is asking that I need a video player. I don't care where you're giving me that video player from. You're going to give me that video player anyhow, correct? So that is how you make that video player in KMP, right? So in this KMP, you are writing this actual fun video player, and this, what you are doing is you are creating a YouTube, let's say a YouTube player view, and this YouTube player view is being implemented in the Android way, right? And then the actual pattern is using it in the iOS way. So in the code that is the shared code gets access to just this video player, but in the background, what is happening is it is taking this like Android implementation and the iOS implementation separately, depending on which platform it is being used in, correct? So again, ask me questions. I know this is a bit technical. So if you get stuck somewhere, feel free to ask. So so that is one thing. How is the support for KMP libraries? Not all libraries are created equal. Problem is, if you have a JVM, let's say if you have a library that is Java dependent, right? You have a Java dependent library. Your Java dependent library would not work in a KMP file. Your problem with that is, I'll tell you, when like if you have Java code in your library, when you are trying to run that into an iOS, it would not be able to convert to that version that iOS can understand, right? So you need more Kotlin only libraries for it to work. I'll give you an example. So let's say you are using Retrofit, is a library we use in Android to make an API call, correct? But Retrofit will not work in iOS because it has Java code in it with Java annotations and all that. So we use something called as a coin, right? For advanced implementation, let's say we are using dependency management, right? So like again, dependency injection. I know people using this term. I'm like, it's such a big term, right? In the end, what it means is you just make the food and just send it where it is supposed to go, right? I mean, people make it so complicated for no reason. But yeah, like just prepare when you're preparing that food. You put so that dependency injection library, you would not be able to use Dagger or Hilt, which is another dependency injection library in Android, using something called as so Coin instead, right? So which is a Kotlin only written development, also a Kotlin only written dependency injection library. So what JetBrains has come with a klibs.io. It's a you can go there, and what it does is it actually you can search what your targets are. So let's say you want to target Kotlin native, you want to target WSM, you want to target Android JVM, right? And then you go send there, and you find, let's say you want to find internet, like internet calling libraries or logging libraries or database libraries, correct? So you can do that with klibs.io. Previously, we used to use something called as, this is another library, like it's a repository of libraries. I think this is much better now. I used to use this for Kotlin Multiplatform, where when it was in alpha, it was a nightmare working with KMP in alpha. So I mean, I was tempted to just give it up because it was so frustrating working with something that was in alpha and nothing used to work. But yeah, I stuck with it, and it's slowly getting better with time. So if you see, the multi-platform libraries have increased day by day. They are converting the existing Java libraries to Kotlin libraries, because coming to Eva's question, why Kotlin is better than Java, because most libraries are transferring to it. So yeah, and how to start? So the start is, you just go to kmp.jetbrains.com, right? I think if you are a Flutter developer, you already know Android Studio. If you are a Spring developer, you know IntelliJ IDE, right? If you are a KMP only developer, you know Fleet. So KMP works in all of these IDEs, and there is a, like, since it is made by JetBrains, like, so KMP is like, so JetBrains was like, okay, you use my tool, all my tools will support you, like you just have to make it, kind of thing. Because it was since KMP is heavily supported by JetBrains, and our IDs, Android Studio, Fleet, IntelliJ IDEA, are made by JetBrains, it's the same company. So the tooling support is also better. Again, why Kotlin is better than Java. I'm pushing this joke too far, but yeah. Anyway, so the next is, how do you do it? So you go to kmp.jetbrains.com, and you select what are your targets. You select, let's say you want to start a project with Android, want to start a project with iOS, you want to start a project with desktop, and then once you are done, you just go to, you just make that starter app. In the meantime, since you already saw this, let's try to see if I can get the JVM equivalent of it. It takes it, like, my system might shut down, so I don't know. It takes a lot of space and time to run. So patience is the biggest virtue of an Android developer. We do not have hot reload like Flutter, so yeah, pain. Anyway, so next is, for example, is KMP ready to be used in production? Yes, it is. We have all of these users. We have all of these companies that are using Netflix and you KMP in production now. They are leveraging it in your leveraging the uh, yes, it is hot reload. I mean, God, we wish we had that. But anyway, anyway, that as a Kotlin multi-platform is used in these places, because when you are showing a list or showing any sort of like things that are targeting both apps, and they are not very they are very system heavy. For example, there is a photo feature, or there is a Bluetooth feature, or there is a Bluetooth feature, or there, let's say, something on the bare metal, sensors, correct? All of these places, Kotlin multi-platform shines because you are using the native libraries, correct? So should I do Flutter or KMP? I think I can. I am getting into very scary territory now, but I'll try to be as unbiased as possible. Right. So first is like, let me see. Yeah. I'm just kidding. I'm just kidding. I'm just kidding. Don't get too mad at me. I mean, so yeah. So this is. I'm just kidding. Gosh. Actually, where does Flutter shine? Flutter shine, first is hot reload. Flutter shines because, let's say you already have you already are starting something from scratch, right? And you are trying to build something. You'd probably use Flutter there, because you do not have anything yet, and you are starting something from scratch, and it is a landing page, right? Because Flutter UIs are like, it looks pretty good, correct? So like this, there is like the debugging time is also less, because since it is widget based, the chances of error is also less since it is declarative. The errors are less. Correct. The designs like Flutter widgets are so much more customizable with the new impeller engine updates. It's amazing, right? Like it has become much faster. It has become much. The size is also reduced. Correct. And it is great if you do not have anything. Yeah, it does. But the Flutter engine is kind of to convert that code. It shifts that engine with it, right? So the size of the code increases. So I think Flutter is a very good thing to use there, right? Now coming where to use Kotlin multiplatform. Kotlin multiplatform would be great. Let's say if you have an Android app already, and you want to convert, say that okay, suddenly I did not expect to be this successful with my startup, right? I now want to target iOS as well, right? So that would be a very good place where you would use KMP because the amount of code that you have to shift over is very less because you are writing in the same language. Kotlin is the language that you use for your Android app. You're just shipping it to iOS. Let's say, but you have an iOS app and you're shipping it to Android. If that's the case, I think there's a new multi-platform thing on the block which is by Swift. I don't remember it very well, but that would be a better advantage. So that is one. Second is if you are using native components like sensors, camera is very good because even Flutter apps when the debug bridge that they use, like the native hook that they use for camera is very good. So it almost feels like you're using the native camera. But for other places where you are using, let's say, sensors, or let's say you are making an AR app, right? Or you are making something which is very heavily dependent on the base metal of the app, right? Let's say emergency, tremor detection, all of these, right? So these kind of apps, KMM will shine, correct? Also, the problem is KMM is very new. KMM is not new per se, but the support for KMM is less because we use the number of libraries are very low. Flutter is much more mature, right? So you would be crying less now if you start KMP now. But I have definitely cried a lot when I started KMM when I started with KMM development in 2021 where it was in alpha. Build Gradle, oh my god, Build Gradle is a nightmare in KMM. Like in 2021, it has gotten a lot more better with JetBrains tools, but getting those different targets and getting those, like just I remember I spent 11 hours just to get this app running. I mean, I don't know if I ever seen that many errors in one time. Like the number of errors, I thought my whole ID was just red because I had forgotten how a normal non-error message looks like. But yeah, that is one. Otherwise, I don't have a Mac right now. That's a big question. I don't have a Mac. Can I do KMM? The answer is the same. If you don't have a Mac, if you see my KMM project here, we do not have that. That we have a web app target, but we do not have an Android target because I am showing it from an Android laptop. If I switch over to my iOS laptop and uh, like thank you, welcome to my cult, right? So if I switched over to, let's say, my Mac app, MacBook, and I try to run the same app, it would actually show the iOS target as well, correct? So that is so even though you have I precisely used the desktop just to show you this, that
It's 6 o'clock.
it's not a, that's why I was talking, by the way. But yes, so when you are seeing this, you can see that iOS target is not being shown, and this is not like a, I mean, not a problem of the KMM people, but actually it's a problem with Mac OS. The Mac is like, sorry, I know we don't do that here. I'll show you through like what a normal KMM project, right? Let me try. I'll give you an example. What uh, for example, the JetBrains Toolbox app, right? This is also made using KMM, correct? Now, let's say I want to switch to a KMM app. I'll try to give you an example there. So I use IntelliJ IDEA because I find its auto suggestion best, and it kind of works properly. If this is just a hobby project of mine. So I was working on this a few minutes ago, but what it does is, let's say, if I go to the structure of the app, basically this is an app that is using Kotlin Kotlin Multiplatform and Compose Multiplatform. So here I am sharing both the UI as well as the you know uh, both the UI as well as the business logic. So that is how it looks. If I go to the most fun is actually here. Where's the gradle? Yeah. So if you see here that there is a lot of targets, correct? I don't know if it's visible. Let me try to bring it up. Is that okay? So if you see it here, there's a iOS target, right? Then there's a common main dependency. There's a common test dependency. There's an Android main dependency. There's an iOS main dependency. So what is happening here? So let's say I want to use something specific to Android, right? I want to use, let's say, a AR library in Android. I would do that in the Android main section. If I wanted to use something that was in the iOS block, I would use it in the iOS section, correct? So other than that, common test is the place where you are using libraries. Common main is the place where you're using libraries that would work in both Android and iOS. That is the multi-platform compatible libraries, correct? So that is the Gradle. This is much easier now. Like it runs now, which is a big thing for me. But other than that, let's say you let me go to the expect. I don't have an expect actual yet. I don't think so. But basically, if you see the common main section is the section where you write the code that is common to both, right? And then in the Android main section, you write the section where you write code that is only for your Android or only for iOS. I'll give you an example. Let's say I try to make something here. Let's say I'll go to Kotlin here. I have pressure. I write like a class, and hello. I don't know if it will work, but yeah, expect fun get platform, correct? So if I once I have expect fun get platform here, I'm expecting to use this in the Android section as well. So Kotlin will also have hello, right? I have hello here, and I write actual actual hello world. What is that? Was labeled on actual fun gate platform. This is Android, and then let me do it in iOS. Right. Where's iOS? Where's iOS? Yeah. So this is funny. Even though I'm not on an Android app, I mean, an iOS phone, iOS laptop, I can code here in iOS as well. It's just that I won't be able to test if I am right. So if you are feeling particularly very, very brave on a Friday, you can definitely do this, code it in iOS, and just ship it and hope it works. So that's one of the daredevil challenges you have to do when you're doing campaign and in a Windows machine. So I write an actual class, and actual hello. What's the type again? See, it does not give me the auto suggestion anymore because I am not using iOS, so it does not get what I'm typing. But yes, that's like a few problems of. So it'll probably like I'll do something like iOS. Correct. So it's NS string if I'm not wrong, but this is how it actually works. So you have a hello. So thing to note, keep in mind that this is in the main kind of hierarchy. So you have a hello.kt file where you put that expect fun get platform name, and then you have an actual section here in Android main and iOS main, which in the same hierarchy, and you put the actual definitions of it, and the output of both of them are kind of different. So this is like how it essentially works. I think that would be good as a starting point as to how you can play around with KMP. Again, available everywhere. Just hit me up and I'll solve your problems. So yeah, any questions?
So, just one question in our chat: why is Kotlin better than Java? But I think that you answer on this question very deeply. And I had one question from my side, but you answer it before I type this question. So
Yeah,
I
yeah,
was
yeah.
wondering if it's possible to run iOS, but now I understand that yes, it's possible. So, for example, if I'm Mac user, I mean iOS user, it means that I can run and test. Yes, so it's something similar to Flutter.
Yeah, yeah, it's the same as Flutter. Even Flutter, if you see, in Flutter, there's a part, right, where you have like a Android specific platform check that if get platform is iOS, you write this iOS code, which is native code, and you write if you use Android, use this code. So that demarcation is done in Flutter as well, right? So, but here it is baked into the system only. So the expect actual pattern basically, like if I call this, right, if I call get platform name, I do not have to even tell the code that where am I calling it from. It will automatically understand that it is being called from an iOS or an Android. So,
Oh my God, it's something new. I need to try
yeah, yeah,
because really you impress me by your talk. Now I start singing because you know that the main feature of Flutter is in its multi-platform. Why it's so popular because one code base Android, iOS. But after your talk, I understand that not only a Flutter so multi-platform.
right. Welcome to my cult. That is why I do what I do. But but welcome to the Kotlin multi-platform cult. And
Now I
I
understand
believe
that
that.
your task is to impress, yes?
Yeah, 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 absolutely.